Alright, so today I'm going to talk about chemical mixtures. A mixture is a combination of some particles, referred to as a particulate, such as, say, dirt, mixed in with a medium, such as water. There are three types of mixtures: solutions, suspensions, and colloids. I will start with solutions. In a solution, the particulate is referred to as the solute, while the medium is called the solvent. This is because the solute actually dissolves in the solvent, forming the homogeneous mixture that is a solution. A homogeneous mixture is where the particulate, which again is called the solute in this case, is evenly distributed at the chemical level throughout the medium, again referred to as the solvent. A good example of a solution is salt water. In this case, as you can possibly guess, the salt, which is the solute, dissolves in the water, which is the solvent. It does this due to the various chemical properties of water, most notably water's polarity. While I won't explain polarity here, it works by having water stick to the individual elements in salt in much the same way a magnet sticks to a paperclip. Due to this bonding between a solvent and the solute, solutions cannot be separated using a filter or any other mechanical means. To separate a solution, you need to use some chemical means. In our saltwater example, evaporation would be the most common. Before I move on, I thought it was interesting to note that air is also a solution, with nitrogen as the solvent and all the other gases as the solutes. Next, we will move on to a suspension. In this case, the particulate is only suspended, as the name might suggest, in the medium and does not actually dissolve inside it. As such, solute and solvent are not applicable terms, and the mixture is heterogeneous. Heterogeneous is the opposite of homogeneous, means that the particulate is not evenly distributed throughout the medium. Furthermore, whereas solutions could only be separated chemically, suspensions can be separated through mechanical means, i.e. by using a filter. In fact, the key thing that defines a suspension is that after a little bit of time, the particulate will separate out of the medium on its own. A good example of a suspension is dirty water. For example, say you are at the beach and you throw a bunch of sand into the water. For a little while, the water will be cloudy due to the sand, but after a bit, the sand will settle to the bottom and the water will be clear again. Lastly, we have colloids. Like suspensions, they are heterogeneous mixtures, meaning that the particulate is not evenly distributed throughout the medium. However, unlike suspensions, where you can kind of tell where the particulate is, it is often impossible to tell where the individual particles are in a colloid, especially with the naked eye. They are like solutions in this respect. Also similar to solutions, and unlike suspensions, is that colloids are stable, in that the particulate will not separate from the medium, at least not until after a very long time. However, unlike solutions, colloids can be separated mechanically, such as with a filter. Furthermore, colloids, as well as suspensions, exhibit something known as the Tyndall Effect. This is where light is scattered due to the particles in either a suspension or a colloid. If you were to shine a light in a solution, the light would just pass through because the particulate is dissolved at the molecular level, while shining a light through a colloid would light up the mixture due to the comparatively much larger particles. A good example of a colloid is milk, with its fat globules in water, or fog with its water droplets in the air. In either case, you can't see the individual particles, unlike the sand in the suspension. However, in both cases, light is very easily reflected due to Tyndall scattering. In fact, this is what makes fog so hard to see through. But, nevertheless, hope you enjoyed it, hope you learned something, and see ya.